Okay, we are back with page 2, and we are still in 12.2, which is about circles. And example 2 says to write the equation of the line that is tangent to the circle at the given point. So we want to write an equation of a line that is tangent to the circle at whatever our point is. So in order to do that, we're going to take what we know about the tangent lines sorry, bless me. We are going to take those and we are going to use what we know about perpendicular lines. And when we write an equation of the line, you can write it in slope-intercept form, or you can write it in point-slope form. So step 1, identify the center and the radius. So the center, H and K, if you don't see anything added or subtracted, then we know that the center is 0, 0. And then your radius, if r squared equals 29, to find the radius, you always just have to square root both sides. So when you take the square root, your r value is the square root of 29. We don't have to worry about the negative case here because it is on a circle, it is a distance, so it is going to be positive square root of 29. And we are going to leave that as an exact value. All right, now we're going to find the slope of the radius at the point of tangency, and that's going to help us find the slope of the tangent. Okay, so we have this circle and then this point, so we are going to find the slope at the point of tangency, and to do that we're going to use our slope formula. So the slope equals y2 minus y1 over x2 minus x1. So we're going to use the center, 0, 0, and the point, 2, 5. Okay, so then here's your x1, y1, your x2, y2. So to find your slope, you're going to do 5 minus 0 over 2 minus 0. Okay, so this is the slope for the radius. What we need to do is find the slope for the tangent line. Well, what we know is that these two lines are perpendicular. You might remember from Algebra 1 or geometry, the slopes of perpendicular lines are, you can think of them in two ways. Sometimes you'll hear them as opposite reciprocals, or their product is -1. So the opposite refers to if it's positive or negative. The reciprocal is going to be the flip. Okay, so the slope of the tangent would be the reciprocal, 2/5, and then the opposite. Okay, and then again, if you multiplied 5 over 2 times -2/5, you would get -1. Okay, so now that we know the slope of the tangent, we're going to use the slope-intercept formula to write our equation of the line. All right, so your slope is -2/5, and your point, 2/5, is going to be your x1, y1, and we're going to plug it in here. So y minus 5 equals -2/5, x minus 2. And then we are going to simplify. So if we distribute -2/5 times -2, a negative times a negative is a positive, so this is +4/5. And then we will add 5. So y equals negative 2/5 x. And then we're going to turn this into an improper fraction. So 5 4/5. 5 times 5 is 25, plus 4 is 29, so this is 29/5. Okay, and then an easy way to check it is to graph it. I didn't put that on here because I was trying to keep it a little bit shorter, but I am just going to show you the picture of this, and you can graph it. I might even suggest graphing it on Desmos, because you can enter in the circle equation just how it is to check and see that that is going to be your tangent line. So here's your circle, center at 0, 0, and then your line. If you did want to enter this into your graphing calculator in rectangular coordinates, you could enter in the line, but you could also solve this for y. So if you solved this for y, it would be y squared equals 29 minus x squared, and then you would take the square root. So let's see how that looks in our graph. Okay, so the square root of 29 minus x squared. I'm going to see if this will do it in the rectangular coordinates. It just does half of it, and if you want to know why, it's because you'd have to put in the negative one too. The negative one will give you the other one, because when you take this, you do the plus or minus. 29 minus x squared, and this is just extra stuff. I know some of you are probably like, well, why are we looking at it? It is helpful to see a few things. If you go to zoom square, then it won't look like an oval anymore. It'll look like a circle. So beautiful. And then if you just put in your tangent line, which is negative 2/5 x, plus 29 divided by 5, then you're able to see, oh yep, it just hits it in one point and keeps going. All right, good times. I'm going to do another video since the next part starts 12.3.